Qualitative analysis of anions. This video clip demonstrates how to identify common anions. To analyze what anion is in the sample, we can add the appropriate reagents and observe the chemical changes. The following parts demonstrate the testing methods for common anions and the expected observations. Chloride ion. Halide ions can be identified by silver nitrate solution. Add silver nitrate solution to a solution containing chloride ion. A white precipitate is formed. The white precipitate is silver chloride. It is insoluble in water. If excess aqueous ammonia solution is added to the precipitate, the white precipitate will dissolve and a colorless solution will be obtained. Silver chloride reacts with ammonia to produce water-soluble diamine silver ion. In addition, if the precipitate is exposed to sunlight, it will turn gray in color quickly. Bromide ion. Add silver nitrate solution to a solution containing bromide ion. A pale cream precipitate is formed. The pale cream precipitate is silver bromide. It is water insoluble. If excess aqueous ammonia solution is added to the precipitate will dissolve slightly. If the precipitate is exposed to sunlight, it will turn gray in color slowly. Iodide ion. Add silver nitrate solution to a solution containing iodide ion. A pale yellow precipitate is formed. The pale yellow precipitate is silver iodide. It is water insoluble. If excess aqueous ammonia solution is added to the precipitate will not dissolve. If the precipitate is exposed to sunlight, it will not change in color. In addition, halide ions can also be identified by chlorine water and organic solvents. Add chlorine water to the sample solution, followed by an organic solvent. Shake the sample and observe the change. If the anion in the sample is chloride ion, there will be no observable change. If the ion in the sample is bromide ion, the organic layer will change to orange in color. It is because the bromide ion is oxidized to bromine by the chlorine water. Bromine dissolves in organic solvent to form an orange solution. If the ion in the sample is iodide ion, the organic layer will change to purple in color. It is because the iodide ion is oxidized to iodine by chlorine water. Iodine dissolved in organic solvent to form a purple solution. Carbonate ion. Carbonate ion can be identified by adding an acid. such as dilute hydrochloric acid or dilute nitric acid, to the sample solution. If the sample contains carbonate ion, a colorless gas will be produced. It is carbon dioxide. If the gas is allowed to pass into lime water, the lime water will turn milky by the carbon dioxide. Hypochlorite ion. Hypochlorite ion is alkaline and has bleaching power. Hence, it can be tested by red litmus paper. Stain a piece of red litmus paper with a solution of hypochlorite ion. The litmus paper turns blue and is then bleached to white. Sulfite ion. Sulfite ion has reducing power. It reacts with strong oxidizing agents. For example, if acidified potassium dichromate solution is added to a solution containing sulfate ion, the potassium dichromate is reduced and turns from orange to green. Similarly, sulfite ion can also reduce potassium permanganate. It changes acidified potassium permanganate solution from purple to colorless. Sulfite ion also reacts with bromine water and changes brown bromine water to colorless.